So let me add a rectangle, because remember, in my main method right here, I still have a rectangle which is undefined, which probably will make the compiler very unhappy if I ever try to compile this. So let's add another class named new class, Java class named rectangle. Okay, and just finish that, and definitely I need to do the same thing. Extends base shape, right? And very likely that for the rectangle I need another set of x and y coordinates. I will say private, as we'll already learn. Keeping internal data private is a good idea. It's a basic rule of encapsulation. But I will name this x2 and y2 because it's so so obvious that this is a second point which specifies the rectangle. And so once again, my approach to define a rectangle, that x and y is right here, x and y, and x2 and y2 are specifying this diagonal point across the two opposite angles of the shape, right? So this is how I set up my rectangle. And so in memory, I need to store x and y, which comes from the base shape, and x2 and y2, which I'm adding to my rectangle. Okay, so extends base shape. We immediately do recognize that we need to have a constructor to be able to construct the rectangle. And of course, it needs to be able to initialize it properly and put this object into a reasonable initial state. I need to provide both int x, int y, and then also int x2 and int y2. So notice how I am very staying pretty consistent with naming those things. So I really don't invent new names. If in my mind this is x and y, I'm not giving them different names. Instead, of course, I will say superclass, take x and y. Superclass is, of course, the base shape. So the x and y will take this thing, x and y, and then of course I also need to say this x2 equals x2 to initialize the the data attributes defined at the rectangle level, and then of course say this dot y2 equals y2. Okay, so this is my approach to this, and I am expecting that my main method now should be able to instantiate this rectangle. So let me give this a try just to see if there are any errors, if there's anything that I haven't been thinking about. So I'm just going to say clean and build, see what comes back as a result of that build. And it says invalid, what it says here, let me just minimize the size of this so I can see. Invalid method declaration return type required, and that goes here. Public rate. Oh, this is because I misspelled the name of my class in my constructor, so it just didn't know that it was a constructor. All right, very well, then save this. So this time I should be able to build it without a problem, right? So I just go and clean and build. So this really doesn't do anything interesting so far, right? So we have a base shape, we have a circle and a rectangle, and of course it would be useful to say that public void move should probably be defined somewhat different for a rectangle. If for the circle we just said that the base shape takes care of the move of the center point, because we said that let's for circles x and y will represent the center point. In fact, in my constructor, I can add a comment that when I call my superclass, the base shape superclass constructor, this means that we initializing the center point. Okay, initializing the center point. Make sure we spell this right. Okay. So therefore we decided that if we need to move, all we have here is that the move inside the base shape already moves successfully the drawing primitive around the plane. Simply by updating the position of the center of the circle, it should move just fine because the radius remains the same. Okay, with the rectangle, however, the move has to affect all of the basically we have to move both those diagonal points. Therefore, if we say move by int delta x and int delta y, then perhaps what we can do here is that we can ask the base shape to update the coordinates of the first point, the point x and y, right? So if we need to move the shape around the plane, right? So we need to move, like, few units down and few units to the right over there, right? So what we need to do is we need to update the coordinates of this point, and we need to update the coordinates of this point likewise. So let's do this. So let's first say superclass, which is the base shape. You have the move method, and so go ahead and do the move for us, right? So we can just directly tell the superclass. This is the way you can talk to the superclass and say, superclass, move your x and y point by these two offsets. But then we can clearly do the same thing here and say, now x2 plus equals dx, and of course y2 also plus equals dy. So this way, what we just did is that we just overridden the move method for our rectangle. So we can perhaps try override annotation here, and as you can see that override is guaranteeing this annotation, Java annotation override is guaranteeing that there is indeed a method in the base class, in the superclass, which is named move, which does indeed takes two integers and returns no value. So that the signature of the method matching what we're trying to do in the subclass perfectly, right? So this is an exact signature of that method. So if I wanted to change this to be an int, right, the compiler will be unhappy and will say, no, in fact we can try saving everything and building it now, right? And the error message says here, error, move int in rectangle cannot override move int in base shape. As simple as that, because simply a return type int is not compatible with void, right? In base shape, we decided not to return any values back, whereas in rectangle, perhaps by mistake, we thought that we need to return an integer back. So I'm going to change that back, and that's a standard procedure to redefine or override, which is suggested by this annotation of Java that says that we're trying to redefine this, but as you can see, it's perfectly okay to delegate part of the work to the base class. Now, back to this view. Here's another observation. I think about rectangles, I think about circles, I think about other shapes, even including text, right? And at the same time, I think about this base shape which provides X and Y. But what about methods? How come that when I think about my shapes and how much perhaps memory those shapes take in memory when the objects are instantiated, how come I'm not really adding instantly methods to this picture? So let's just talk about another internal detail about data attributes versus methods available to our objects, and what effect do our objects have as a result of adding attributes and adding methods to the sizes of our objects and to the internal structure of what is used at runtime. So